Hi everyone, welcome back to my channel. It has been a long time that I haven't posted any video, and today is my birthday, and so I'm going to start an ECG course, study from today, free ECG course. It is the first introductory ECG video, and I will post many more videos later on. Okay, so let's start our video here. Today, I'm going to talk about the background of ECG, ECG terminology, and about early ECG and other additional leads and ECG format. So let's start with the background of ECG. When I'm going to read about ECG, I think that, how we record, how the previous our legends record the ECG, and what is the previous background of the ECG, and why the ECG waves are named P, Q, R, S, and T, and U. And so this is the first thought that came into my mind when I started to read ECG. And so I search back to the history. So this is the capillary electrometer developed by the Liebman in 1873. Liebman developed the capillary electrometer. It is just to measure the some density and some measurement regarding the mercuries and other ions and other electrolytes. But by using this Liebman capillary electrometer in 1887, Waller can trace the cardiac contraction by using this Liebman electrocardiometer. Capillary electrometer. It is an electrogram, and he recorded this. And at first, it is the very original basic of the ECG. At first, he can only trace that two waves are regarding the ECG contraction. That's why he named these waves V1 and V2. He names it might be due to the ventricular contraction. So this wave as V1 and the other as V2. So initial ECG have only two waves as V1 and V2. Okay, it is in 1887. Okay, in 1895, Einthoven. I think you all might know the Einthoven because he is very famous regarding the ECG. Einthoven found out that there are more than two waves, more than V1 and V2. There are four waves of the ECG, and he named these waves as A, B, and C, and D. And so here, it is the A wave, it is B, C, and D, A, B, C, and D. It is the waves recorded by Einthoven. Okay. Later on, and he found out that there is not only four waves, there is basic 5 waves. And so he named this PQRST. Okay, wait for me. P, Q, R, S, and T. Here. And so after that, he found out that there are more than 4 waves, and there are total 5 waves, P, Q, R, S, D. So why he named it, that he gave this name PQRST? Why can't he simply put on ABCD plus E, ABCDE? Because at the time, he thought that ABCD are wrong waves. He previously recorded. So he doesn't want to use this naming system into the correct waves. And so he try to choose another alphabets to name these. And so there are two theories, two concepts that why PQRST is used. And the first thing is that he want to put another alphabet. So instead of ABCDE, he can use XYZ study from the back. But the XYZ is XYZ is very famously used for the mathematical equation, mathematical axis and diagram. So he chose the middlemost word of the English alphabets. And so for the middlemost word, it is N, N. So these waves should be termed NOPQR. At the time, he think that the O is like we use the O for nil, zero, and O is something innate. And so he doesn't like O, and that's why he used the alphabet after O, so P. He doesn't use NO, he exclude NO from the list, and so starting from the P, he named it as PQRST. It is one of the concept. Another thing is that he adopt the name of the name named by the Descartes, who named PQRST for successive waves on a graph. He is a mathematician or physicist, someone, and he named the PQRST for successive waves on a graph like P, Q, R, S, T. So it is also a graph. The ECG is also a graph, and so he named this as the Descartes PQRST. It is another concept. Okay, whatever. Now we are using the PQRST for the ECG. Okay. So, sorry. Okay, so it is the background of ECG. And after that, I'm going to talk about the terminology of the ECG. Okay. When we talk about ECG, we are going to say wave, complex, segment, interval, like that. Okay, so what is a wave? Wave is the single positive deflection or negative deflection. Okay, it is the single positive or negative deflection. Positive deflection means upwards, negative, like that, only single. Okay, so what is complex? It is the combination of the waves. So for the waves, like P is the wave, Q is the wave, T is the wave, U is the wave, S is the wave, R is the wave. But for the complex, it is the combination of the waves. So QRS is the complex. We don't use P complex, we don't use T complex, we only use the QRS complex. Okay, so what is segment? Segment is normally on the isoelectric line. When we use the term segment, there must be no wave in between, So when we use the PR segment, it is the state of, N of P2 state of QRS. It is the PR segment here. There is no wave in between. But if we use the PR interval, there is a wave in between. It is the distance, and there is a wave in between. So for PR interval, instead of P2, instead of QRS, so P wave is there in the interval. For SD segment, it is that N of S2 instead of D, no wave in between. For QT interval, it is the state of Q to N of T, therefore QRS and T wave in between. Okay, are you okay? Okay, and so for the wave abnormality, we can say the width of the wave or height of the wave, height or depth of the wave. For example, for P wave, if the wave width of the wave is greater than the 2.5 small square, it is the atrial hypertrophy, left atrial hypertrophy. And if the height is higher, it might be the right atrial hypertrophy, like that. Okay, and also there is an abnormal shape morphology, various P wave morphology in multiple atrial tachycardia, like that. Okay, for the complex, their abnormality might be wide complex or narrow complex, like VT and SVT. And for the segment, it is the elevation, like SD elevation in the MI, and depression and ischemia. For the interval, we usually use the shortened interval, short QT, long prolonged interval, like long QT syndrome. Okay, here are the terminology. So sometimes we are confused with the term interval and segment. And so interval is something that is no wave, there is wave in between, and segment is no wave in this. Okay, another term is the R wave peak time. It is, it might be strange to some new learners, and it is the R wave peak time is the time taken. It is the time interval between the onset of the QRS complex to the peak of R wave. So we use R wave peak time instead of QRS to peak of R. Actually, it represents the time taken to depolarize from endocardium to epicardium. So that means that if you have the ventricular hypertrophy, the R wave peak time will be prolonged, and if normal, it will be within the normal limit. Okay, so normal R wave peak time is less than 0.45 seconds in V5, V6, and less than 0.35 seconds in V1 and V2. So usually when the R wave peak time became prolonged, it is seen in the banda branch block and ventricular hypertrophy, because it is the time taken from depolarize from endocardium to epicardium. It might be the new term for you, and please keep in mind this. Okay. It is the terminology, ECG terminology. And another thing is the Twelve-lead ECG, and its placement. Okay. For the 12-lead ECG, I must first tell you about them. What is the 12-lead ECG? Actually, to record the 12-lead ECG, there are 4 electrodes on the limbs. What we name is the RA, LA, right leg, right arm, left arm, right leg, left leg. Okay, 4 electrodes. And there are 6 electrodes on the chest. So it is V1 to V6. Okay, actually, and the first thing is that Eindhoven named the name lead 1, 2, 3, which are the bipolar leads. Bipolar leads mean the ECG leads detects the electrical exponential difference, not at the single point. It is the difference between the 2 points. And later on, Kohlberger named AVR, that is augmented voltage right arm leads. Yes, no? Augmented voltage right arm. No. AVL left arm, AVF foot. It is the unipolar leads. Action potential at a single point, unipolar leads. Okay, and later Wilson name V1 to V6. They are also the unipolar leads. No, so Enthoven, Kohlberger, and Wilson names our 12-leaf ECG. Okay, and so what is the 12-leaf ECG? I'm going to no enough space, but I will try to draw here. Okay, so here is the right arm, left arm, and the right leg is the electrode leads, ground leads, and so we take into the left leg, only left leg, and so it becomes a triangle. So right arm to left arm is action potential difference. It is what we call is the lead 1. Lead 1. Okay, left arm to left leg. It is the lead 3. Right leg to left leg. It is the lead 2. Okay, so let's draw this on this axis. Okay, lead 1. No, it is there, since left leg is in the central, it becomes the triangle with a similar angle. So it is the they all are the 60 degree, 60 degree. Okay, so here. So here is the 60 degree. So that there might be there is the 30 degree here. Like this also. It's the lead 2. No, lead 2 like this. Lead 2. Lead 3 like this, or this lead 3. It is the lead 1. Okay, so this is there is the 60 degree here. 60 degree here. So that this 30 degree, the total 90, and plus it is the 60 degree here, because here is the 60. So there might be the 30 degree. So for the lead 3, if studying from the lead 1 here, it might be the 120 degree. So say 60, 30, and 30. So 120 plus 120 is the plus, is the plus 60 is U. Okay. Okay, another thing is that then we use the central points of this triangle, and that divides the here and here. So we name this as AVL. It is to the right side, so AVR, to the foot, so AVF. So AVF is so AVF is here. It is plus 90 degree AVF. For the AVL, it comes like this. It is the half of the 60 degree, and so 30 degree, half of the 60 degree. So minus 30 degree, it is there. AVL, it is also 30 degree. So 30, 90, and it is the 60. It is 30, so it is minus 150 degree. It is the AVR. I will. Okay, so now we got there interval triangle. It is the where lead 1 is 0 degree and lead 2 plus 60 degree, lead 3 plus 120 degree, AVL minus 30 degree, AVR minus 150 degree, and AVF plus 90 degree. Okay, that is the what we plot it. We plot this triangle on this axis. Okay, and so for the axis, I will discuss about the axis on the later video, and but it is for Reg. The normal axis lines between the here normal axis, and for this side, it is the axis goes to the right side. So right axis deviation, it is the left side. So left axis deviation, and it is the, you know, in their map, it is the north, east, south, west, and so it is the north and west, between north and west. So we call it northwest axis or extreme axis. The heart is extremely rotated, so extreme axis. You know, it is the rough recall of the cardiac axis, but what I will discuss about it in today. Okay. Okay, so I have discussed about the 12 lead ECG and also the limb leads, and now is the time for chest leads. And so what are the sites for the chest lead? And so V1, for the V1, it is the fourth intercostal space, right sternum margin. For the V2, 1, 2, 3, 4, fourth intercostal space, right sternum margin. V2 is the same, left sternum margin. V4 is the mid-clavicular line, fifth intercostal space. It is one space below. So fifth intercostal space, mid-clavicular line, left mid-clavicular line. V3 is the midway between V2 and V4. For the V5, it is the fifth intercostal space, left anterior axillary line. And V6 is the fifth intercostal space, left mid axillary line. Okay, so we use the 10, V1 to V4 for the anterior leads, and V5 and V6 for the lateral leads, because it lies laterally. Okay. Okay, so in this here, we'll use AVL1 for the lateral leads because it lies laterally, and 2, 3 AVF for the inferior leads. It is the RV lead because it is listed in the AVR. Okay. So sorry, not RV lead. Okay. Another thing is that how will you, or that this is the basic leads. Basic what we usually do is this lead placement. But in case of RV infarct, posterior infarct, we change the position of the leads to record more precisely. And so for the additional leads, RV lead, how can we record right-sided leads? You know? Yes, and the first one is change all V1 to V6 to opposite sides. What we call V1R to V6R. So V1 here became here, V2 here became here, and V3 to V6 here became here. So change all these. It is the first method. Another one, it is the keep the position of V1 and V2 because it is interfere, they're the same position. No? So keep the position of V1 and V2 in their own position, change V3 to V6 to the opposite sides. So we use V3R to V6R. We can record the right-sided leads with this method too. And the third method, if we are in hurry, we have no time to, if the patient becomes discomfort and he's less compliant, and if we are in hurry, we have no time to change all the leads in the opposite direction. So if we have to choose only one lead to record the right ventricular leads, and we use V4. We choose the V1, V2, V3, V5, V6 in the normal position, but we change the position of V4 to the opposite side. That is the fifth intercostal space, right mid-clavicular line. Okay. V1, 2, 3, 5, 6 in normal position. Change V4 to right mid-clavicular line, fifth intercostal space, it is the V4R. Okay. We can, it is also have a, it can, by changing this method, it can detect the RVMI with the 88% sensitivity and 76% specificity. So it is also a good method to use if you are in hurry up. So another thing is the posterior leads. If we want to record the posterior MI, we can see the mirror image at the V1, or for more precise method, we can use the posterior lead placement. So where do we place? V7 at left posterior axillary line, horizontal plane as V6. The places like the V6, like anterior development, fit intercostal space. V8 is at the tip of the left scapula. V9 and left paravertebral region. By doing this leads, you can see the posterior MI. Okay, so standard leads, RV leads, and posterior leads are usually what we usually perform, but for the another two leads, what we call is the lowest lead and founding leads. It is less frequently used in the clinical practice. Okay, but I will discuss about it. Lowest lead. Lowest lead is used for better visualization of flutter waves, like in atrial flutter, and also for visualization of P wave in white complex tachyarrhythmia. And in this, we use the limb leads, limb electrodes. We remove the clutter and we use the limb electrodes. RE electrodes on the manubrium sternum. LE electrodes on the fifth intercostal space, right sternal border. Left leg electrode on the right costal margin, lower costal margin. And right leg electrode on the right leg. So by using this method, this leads, we can better visualize flutter waves and B waves in tachyarrhythmia. Okay. Another is Fontaine leads, and the lowest lead is lowest lead is discovered by the Sir Thomas Lewis. That's why we use the Lewis leads, and it is the Fontaine leads. It is it is discovered by the Guy Hicks Fontaine, and it is used to see the better visualization of the epsilon wave in arrhythmogenic right ventricular cardiomyopathy, ARVC, and it is like here, like something that is the epsilon wave. Okay, so in this case, RA on manubrium, RA leads on manubrium, LA leads on C5 process, LL on fifth intercostal space, left mid clavicular line. It is like the position of V4, and right leg on right leg. Okay, by placing this leads in this placement, we can better visualize the epsilon wave. Okay, so it is all about the leads. And another thing is the ECG format. We are very used to with the standard ECG format, and it is 1, 2, 3, AVR, AVL, AVF, V1 to V6. But you know, as I said before, one AVL is the lateral lead, and one AVL V5 is the lateral lead, and 2, 3 AVF is the inferior lead. And so the leads are not arranged together. And you know, one and AVL is quite far away. You know, it is the 3-lead ECG. If you use the one lead channel, and the recording will be 1, 2, 3 AVR, AVL. So you have to look for one and then go down, and the AVL is quite far away. And so there is another format that helps us for better visualization of the similar leads together. Similar leads, that mean that consecutive leads together. And so 1 and AVL in the nearest position, and 2, 3 AVF in the nearest position. And so that is carrier format. Many ECG channel, many ECG machine can change from the standard format to the carrier format, but we are very used to with the standard format, and most of the ECG, almost every ECG come with the standard format. So carrier format is less frequently used, but it is also a good method to better visualize the consecutive leads together. So it is the carrier format, you know, AVL and 1 together, 2 AVF 3 together, but V1 to V6 is in the own position. The chest leads are in their own position, but limb leads are rearranged for better visualization of consecutive leads. It is called the carrier format. Maybe sometime, maybe in the future, the standard format might be obsolete, and carrier format may become popular. Who knows? Okay, so this is the end of today's video. Today I discuss about the background of ECG. It is starting from the discovery of the capillary electrometer by the Lippmann, and with this use of the capillary electrometer, Waller recorded V1 and V2, and then Eindhoven found out that there are more waves like ABCD, and then after that he named them 5 waves PQRST. Okay, and then I have discussed about the ECG terminology, about the wave, complex, segment, interval, and maybe a strange term for you, wave peak time. And then I have discussed about the naming system of the 12-lead ECG. Eindhoven, Goldberger, and Wilson named them. And yes, and also how to degree in the axis and Eindhoven triangle. And after that, normal limb placement, and then how to do the RV leads in 3 ways. V1 or V1 to V6 to the V1R to V6R, V1 to V2 in the normal position, and V3R to V6R, or only V4R with all others in the normal position. It has also good sensitivity. And the posterior lead, how to do the posterior lead, and specialties like Lewis lead, discovered by the Sir Thomas Lewis, and Fontaine leads by Garhex Fontaine. Okay, then I've introduced about the new format of the ECG. It is not new. It is another format of the ECG rather than the standard format. It is the Cabrera format, while AVI, AVL, and 1 are putting together, and 2, 3 AVF are putting together for better visualization of the consecutive leads. Okay, in the next video, I will discuss about the ECG ACEs and ECG ACEs, basic interpretation of the ECG, how to calculate the ACEs, and many more. Okay, stay tuned. Have a nice day.